In this video, we will talk about how to solve absolute value inequalities. So let's check out some examples. Let's say we have the absolute value of 4x plus 6 is greater than 10. We want to figure out for what values of x make this expression true. So the way that we do that is we write 4x plus 6 is greater than 10, and we'll solve for x. But then we also write 4x plus 6, and we flip the sign. So instead of greater than, we say less than, and instead of a positive 10, we make it a negative 10. So we'll solve for x for each of these expressions. So for this first one, we want to solve for x. We'll subtract a 6 from each side, and we get 4x is greater than 10 minus 6 is 4. To get x by itself, we can divide each side by 4, and we're left with x is greater than 1. Now we need to solve this expression as well. So to solve for x, we'll subtract a 6 from each side, and we'll get 4x is less than negative 10 minus 6 is negative 16. So to solve for x, we'll divide by 4, and we get x is less than negative 16 divided by 4 is negative 4. So for all values greater than 1 for x, or for all values less than negative 4 for x, this expression will be true. So if we want to express that result on a number line, we could do this. We could draw a number line where this side extends towards positive infinity and this side extends towards negative infinity. And we can mark our points of negative 4 and 1. And we'll say x is greater than 1. Remember, that's one of our solutions. So we'll write an open circle right here. Since x is not allowed to be equal to 1, it has to be greater than 1. So we'll do an open circle, and we'll draw a line extending towards positive infinity. And then our other answer is x is less than negative 4. So since it's just a less than sign, it's not an equal sign, we'll also do an open circle to indicate that negative 4 is not a valid result, but anything less than negative 4, so anything extending towards negative infinity, is a valid result. So that's how we would express that answer on a number line. If we wanted to write that in interval notation, we could write it as negative infinity to negative 4, and we'll write a parentheses, since negative 4 is not included as one of the answers, union with parentheses 1. Remember, we draw parentheses since 1 is not part of the solution, up to positive infinity. So these are the values for x that we're allowed to plug into this original expression to make it true. All right, let's check out another example. Let's say we have the absolute value of 5x plus 5 is less than or equal to 10. So we want to figure out for what values of x can we plug in here to make this left-hand side less than or equal to 10. So the way that we do that is we'll write 5x plus 5 is less than or equal to 10, and we'll solve for x, and then we'll also write 5x plus 5. We'll write the opposite sign. So instead of less than or equal to 10, we'll say greater than or equal to, and instead of a positive 10, we'll use a negative 10. Negative 10. Okay, so we need to solve for x for each of these expressions. So on this side we have, let's subtract a 5 from each side. So 5x is less than or equal to 10 minus 5, that's 5. And we can divide both sides by 5 to get x all by itself. X is less than or equal to 5 divided by 5 is just 1. So x is less than or equal to 1. And then over here we need to solve for x, so we'll subtract a 5 from each side. Subtract a 5. So we get 5x is greater than or equal to negative 10 minus 5, that's negative 15. And we can divide both sides by 5 to solve for x. So we get x is greater than or equal to negative 15 divided by 5, that's negative 3. So these are our two answers. X is less than or equal to 1, and x is greater than or equal to negative 3. So if we wanted to draw that on a number line, we could do this, where this right-hand side is extending towards positive infinity, this left-hand side is extending towards negative infinity. So let's say we have a negative 3 right here, and a positive 1 right here. So x is less than or equal to 1. So we'll draw a closed circle at 1 since x is allowed to be 1. And we also have x is greater than or equal to -3. So we'll draw a closed circle at -3 because x is also allowed to be -3. So it can be greater than -3 and it can range all the way to +1. So that's how we would express that answer on a number line. If we wanted to write this in interval notation, we could write parentheses -3, excuse me, this should be bracket since x is allowed to be -3. So -3 up to 1, and we'll write a bracket on this side as well to indicate that x is allowed to be 1. So any value that we plug in for x between -3 and 1 into x right here, this left-hand side will indeed be less than or equal to 10. All right, let's check out one more example. Let's say we have 4 times the absolute value of 5x plus 2 plus 6 is greater than 22. So we want to figure out for what values of x make this expression true. So to do that, we first need to isolate these absolute value signs. So the way that we can do that is we can first subtract a 6 from each side. So we get 4 times the absolute value of 5x plus 2 is equal to 22 minus 6, that's 16. And now to get the absolute value all by itself, we need to divide each side by 4. So we can get rid of that 4 on this side, and we're left with the absolute value of 5x plus 2 is equal to 16 divided by 4, that's 4. So actually let's write greater than sign right here, greater than sign. So we need to figure out for what values of x make this left-hand side 5x plus 2 greater than 4. So the way that we can do that is we can write 5x plus 2 is greater than 4 and solve for x, and we can also write 5x plus 2, and we'll flip the sign, we'll say less than, and we'll make the 4 a negative, so -4. So to solve for x over here, we can say -2 on each side, and we're left with 5x is greater than 4 minus 2 is just 2. To get x by itself, we can divide each side by 5. So we'll get x is greater than 2/5. And then over here, to solve for x, we can subtract a 2 from each side. So we're left with 5x is less than -4 minus 2 is -6. To get x by itself, we'll divide by 5 on each side. So we get x is less than -6/5. So if we wanted to write that on a number line, we could make some number line like this. And let's say this side extends to positive infinity, this side extends to negative infinity, and let's say our -6/5 somewhere here, and 2/5 is somewhere over here. Now, recall we have x is greater than 2/5, so we don't have an equal sign, so we'll draw an open circle at 2/5. And x is greater than that, so any value greater than 2/5 is valid. And then we also have x is less than -6/5. So it's a less than sign, so it doesn't include the equal sign, so we'll draw an open circle. And anything less than that is a valid answer for x. So that's how we would express this answer on a number line. Now if we wanted to write it in interval notation, we could write -infinity up to -6/5. And remember, we use a parentheses to indicate that -6/5 is not included in the solution. Union with 2/5, again a parentheses to indicate that 2/5 is not part of the solution, up to positive infinity. So these are the values for x that are valid to plug into this expression to make it true. Thanks for watching.